Hello everyone, welcome to my channel. I am Vivek Kaithwas pursuing MTech in IT from International Institute of Professional Studies IIPS GAVV Indore. I hope you have watched my previous video in which we have covered question number 1 to 5 of end semester exam paper of subject Introduction to Data Science and R Language. Today in this video we will be covering remaining questions which were 6 to 9. I hope this video would be helpful to you. Now let's start our today's session. Here is the exam paper which and the remaining questions which were left in the previous video. Now first question is question number 6, part A. Describe how the coefficient in linear regression are estimated using either the closed form equation or gradient descent. So linear regression fits a line y equals to beta 0 plus beta 1 x1 plus beta 2 x2 plus L b beta n xn by estimating coefficients beta. Closed form solution normal equation for dataset X predictors and Y outputs beta equals to X transpose X whole inverse X transpose Y. Now steps form the design matrix X with a bias column 1s. Compute transpose XT. Multiply XTX, then take inverse. Multiply inverse with XTY and result gives exact coefficients. Advantages: fast for small datasets, no need for iterations. Limitations are expensive when features greater than 10,000, matrix inversion costly. Now, objective is minimize and j of beta equals to 1 by 2m and summation of h beta x I minus yi whole square. Now, gradient descent optimization. Objective is minimizing and j of beta equals to 1 by 2m sigma h beta into xi minus yi whole square. So, update rule bj equals to bj minus alpha j upon beta j. Steps: initialize coefficients to 0 for small values, compute gradients for each weight, update weights using learning rate A, repeat until convergence. Advantages: works well for large datasets, efficient for online learning. Explain logistic regression and use the logistic function to calculate the probability of a class for given input sample. Logistic regression predicts probability of a binary class using sigmoid function. Here is the formula where z equals to beta 0 plus beta 1 x1 plus till beta n xn. Now compute linear score z, apply logistic or sigmoid function. If probability is greater than equals to 0.5, then class 1, else class 0. Example, let z equals to 1.2, p equals to 1 by 1 plus e to the power minus 1.2. So it gives 0.768. Thus, the sample belongs to class 1, 76.8 probability. Right, K means clustering algorithm. Discuss how initial centroids influence results. So step 1, choose K number of clusters. Step 2, initialize K centroids randomly. Step 3, assign each data point to the nearest centroid. Step 4, recompute centroid of each cluster. Step 5, repeat steps 3 to 4 until centroid no longer change. And step 6, output final clusters. Influence of initial centroids. Bad initial centroids leads to poor clustering, can produce different results for same data, can trap algorithm in local minima. K means plus plus initialize, improve results using smart seeding. Now, question number 7, part B. We have write a k nearest neighbors knn algorithm using Euclidean distance. Consider a dataset with labeled examples xi, yi, where xi is a feature vector and yi is a class label for regression a numeric target. Algorithm steps: classification. Choose k. The number of neighbors, an odd number like 3, 5, or 7 is common to avoid ties. For a new unlabeled point x, compute the Euclidean distance from x to every training point xi. d of xi, d of x and xi equals to under the root sigma till n and j equals to 1 xj minus xji whole square, where n is the number of features. Sort all training points by increasing distance to x and select the k closest neighbors. For classification, count how many of these k neighbors belongs to each class and assign to x the class with the highest count, majority vote. For regression, take the average or sometimes weighted average of the target value of the k value as the prediction. Question number 8, compare decision trees, random forest and boosting, highlighting strength and weaknesses of each. So in features we have structure, overfitting, speed, accuracy, training method and best used for. So decision tree structures are single tree and random forest many trees or bagging and boosting is sequential tree. Overfitting in decision tree is overfitting is high, and overfitting in random forest is low, and overfitting in boosting is very low. And speed of decision tree are fast, speed of random forest is moderate, and speed of boosting is slow. Accuracy for decision tree is moderate, and accuracy of random forest is high, and accuracy of boosting is very high. And training method for decision tree is greedy splitting. Training method for random forest is random feature sampling. Training method for boosting is learn from previous errors. Best use for decision trees are best used for simple models. Random forest best used for generalization, and boosting are best used for high accuracy tasks. Question number 8b. Explain the architecture and components of Hadoop, HDFS, Yarn, and MapReduce, or describe the advantages over MapReduce. So first we have HDFS, Hadoop Distributed File System. Stores large datasets in distributed manner, consists of name node, manages metadata, data nodes, store actual data, provides replication for fault tolerance. Yarn, yet another resource negotiator. Yeah, yet another resource negotiator. Manages cluster resources, components, resource manager, node manager, schedules jobs and allocate resources, MapReduce, programming model for parallel computation, map phases, process input blocks, reduce phases, aggregates output, advantages, fault tolerance, scalability, handles petabytes of data, distributed processing. Spark and its advantages over MapReduce if you choose this option instead. So Apache Spark is a distributed computing engine that keeps data in memory between operation using resilient distributed data sets, RDSs, or random frames. Key advantages over classical MapReduce: support in-memory computation, so iterative algorithms and interactive queries run much faster than disk-based MapReduce, which writes intermediate results to HDFS after every steps. Now provides rich high-level APIs in Scala, Python, Java, and SQL, along with libraries for machine learning, MLlib, streaming, graph processing, GraphX, and structured processing, Spark SQL. Offers flexible execution beyond map and reduce, including joins, filters, video operations, and complex directly and acyclical and complex directed acyclical graph workflows, improves expressiveness, and performs for many data processing tasks. Question number 9a. Obtain basic logic gates from neural networks. Summarize them in table with number of neurons, activation function, and backpropagation in neural network if any. Answer. So neural network can replicate basic gates by choosing appropriate weights and activation function. So logic gates we have taken are AND or NOT or SOR. Neurons AND gate contains one neuron. Activation function for AND is step or sigmoid. Example weights W1 equals to 1 and W2 equals to 1. So bias equals to minus 1.2, 1.5, and backprop needed, no fixed. And or neurons are one neuron and activation function is step or sigmoid, and example weights are W1 equals to 1 and W2 equals to 1 and bias equals to 0. Minus 0.5. So backprop needed are no, and not contains one neuron. Activation functions are step, and example weights are W. Example weights W equals to minus 1, bias equals to 0.5, and backdrop needed are no backdrop needed. And so two hidden neurons plus one output. Sigmoid or ReLU multiplayer MLP is the example, and backdrop are needed. Compare CNNS and RNNS, GANS, and transfer learning in terms of architecture and applications. So, model CNN architecture is convolution plus pooling layers, and strength of CNN is excellent at spatial feature extraction, and applications are image classification and object detections. And architecture of RNN are sequential recurrent connections, and strength of RNN are handles time series sequence. Application of RNN are NLP speech recognition, and architecture of GAN are generator plus discriminator. Strengths of GNR generates realistic synthetic data, and applications of GAN are image generation and deep fakes. Now, architecture for transfer learning are pre-trained model reused. Strength for transfer learning are faster training, high accuracy. Application of transfer learning are medical imaging and small data sets. Thank you for being in the video to last. I hope this video might help you, and please like and subscribe to the channel, and please stay tuned for more interesting videos. Thank you.